USGS, Yellowstone, showing signs of double eruption. Beneath the serene landscapes of Yellowstone National Park lies a geological wonder that captivates and terrifies in equal measure, a massive supervolcano. While its surface features like geysers and hot springs enchant millions, they are but glimpses of a vast magma chamber simmering beneath the Earth's crust. Recent studies suggest a potentially alarming shift in this supervolcano's activity, signaling a possible double eruption scenario. The most likely explosive event to occur at Yellowstone is actually a hydrothermal explosion, a rock-hurling geyser eruption, or a lava flow. Hydrothermal explosions are very small. They occur in Yellowstone National Park every few years and form a crater a few meters across. Every few thousand years, a hydrothermal explosion will form a crater as much as a few hundred meters across. Though the worst-case scenario for a giant Yellowstone eruption is indeed bad and could have global implications, most past eruptions at Yellowstone were not highly explosive. Of the past 50 or so eruptions, almost all were simple lava flows. If they occurred tomorrow or next year, they would have minimal direct effect outside Yellowstone National Park. As for the worst-case scenario, even previous Yellowstone supereruptions did not cause extinctions, and ash fallout on the other side of the continent was minimal. Shifting magma reservoirs. Recent research led by U.S. Geological Survey seismologist Ninfa Bennington reveals that the magma reservoirs beneath Yellowstone are migrating northeastward. This shift could position the northeastern region of the Yellowstone caldera as the epicenter of future volcanic activity. Bennington's team discovered significant rhyolitic melt storage connected to a deeper crustal heat source, leading them to propose that volcanic activity is now focusing in this area, marking a departure from patterns observed over the past 160,000 years. Understanding Yellowstone's volcanic system. Yellowstone's supervolcano is one of Earth's largest and most complex. Over the last 2 million years, it has unleashed 3 caldera-forming eruptions, each reshaping the landscape and depositing ash and volcanic material across the continent. These eruptions are fueled by rhyolitic magma, a silica-rich, viscous molten rock that accumulates in immense quantities. Earlier studies revealed that rhyolitic magma chambers are fed by reservoirs of basaltic magma, which lies deeper in the Earth's crust. Unlike rhyolite, basaltic magma is less viscous and contains higher levels of iron and magnesium. These differences allow scientists to map Yellowstone's magmatic systems using advanced techniques like magnetotellurics, which measure variations in Earth's magnetic and electric fields. Bennington's team used these tools to identify 7 major magma reservoirs extending from depths of 4 kilometers to 47 kilometers. The most significant discovery was a massive basaltic reservoir in Yellowstone's northeast, capable of fueling rhyolitic eruptions on a scale comparable to past catastrophic events. The threat of a double eruption. Yellowstone's eruption history shows alternating rhyolitic and basaltic activity. However, researchers believe that rhyolitic magma chambers must solidify before basaltic magma can infiltrate, complicating predictions of volcanic behavior. And the northeast region, with its substantial magma volume, could experience both types of eruptions, resulting in a double eruption scenario. In 2015, researchers from the University of Utah made a startling discovery. Yellowstone's magma chamber is far larger than previously believed, with an upper and lower reservoir capable of holding enough magma to fill the Grand Canyon 11 times over. This immense capacity exerts pressure on the surface, causing the land to rise by 1 to 2 inches annually, a reminder of the supervolcano's latent power. Current activity and monitoring. While sensational claims often suggest Yellowstone is overdue for an eruption, experts stress that volcanoes do not adhere to predictable timelines. In March 2023, the region recorded 354 earthquakes, including a magnitude 3.7 quake. These swarms, while noteworthy, are not unusual for volcanic regions and do not indicate imminent danger. Michael Poland, a geophysicist at the Yellowstone Volcano Observatory, emphasizes that 2 conditions are necessary for an eruption: a sufficient volume of eruptible magma and enough pressure to force it to the surface. Currently, neither condition is met, though ongoing monitoring remains essential. The apocalyptic potential of Yellowstone. If Yellowstone were to erupt, the primary threat would not be lava flows but volcanic ash. A supereruption could eject massive quantities of ash into the atmosphere, disrupting ecosystems, halting air travel, and triggering a volcanic winter. Past eruptions like the Lava Creek event 640,000 years ago expelled enough material to blanket vast regions and alter global climates. Recent evidence of previously unknown eruptions further underscores Yellowstone's immense power. Scientists have identified two super eruptions from 9 and 8.7 million years ago, one of which was the largest recorded in the Snake River Yellowstone volcanic province. If another catastrophic caldera-forming Yellowstone eruption were to occur, it would probably alter global weather patterns and have enormous impacts on human activity, especially agricultural production, for many years. At this time, however, scientists do not have the ability to predict specific consequences or durations of possible global impacts from such large eruptions. The 1991 eruption of Mount Pinatubo in the Philippines was about 1,000 times smaller than Yellowstone's largest known eruption. It caused temporary yet measurable changes in global temperatures. The sulfur dioxide emitted from the volcano interacted with the atmosphere, which cooled the Earth's surface for 3 years following the eruption. At the height of the impact, global temperatures dropped by 1.3 degrees Fahrenheit, 0.7 degrees Celsius. The unimaginable force of Yellowstone's Gray's Landing supereruption. Recent studies have shed light on an ancient natural disaster of catastrophic proportions, the Gray's Landing supereruption. This eruption unleashed streams of lava that blanketed an area the size of New Jersey, transforming the landscape into a barren, sterilized wasteland of volcanic glass. If such an event occurred today, the consequences would be dire. States like Colorado, Utah, and Wyoming would find themselves buried under 3 feet of toxic volcanic ash. Massive ash clouds would plunge vast regions into darkness, devastating agriculture, rendering pastures useless, and crippling power grids. Even coastal areas far from the eruption's epicenter would not escape the cascading fallout. While such an eruption is not anticipated in the near future, Earth's dynamic nature keeps scientists on high alert. Beneath the familiar crust that supports life lies a complex system of layers. Earth's core, composed of a dense, scorching inner core and a molten outer core, plays a critical role in sustaining the planet's magnetic field, a shield protecting life from solar winds and cosmic radiation. Discoveries. Beneath the surface. Recent seismic studies have revealed a mysterious new layer within Earth's inner core. The solid inner core, about 2/3 the size of the Moon, is composed of iron and nickel, with temperatures rivaling the Sun's surface. Surrounding it, the molten outer core reaches nearly 10,000 degrees Fahrenheit. Researchers analyzed seismic waves from 100,000 deep earthquakes, some originating over 60 miles beneath the surface. By tracking how these waves moved through Earth, they discovered a previously unknown layer deep within the core. These findings not only deepen our understanding of Earth's structure, but also emphasize its intricate, interconnected systems. Earth's rhythmic pulse and dynamic changes. Did you know Earth has a heartbeat? Every 26 seconds, the planet pulses, a phenomenon first detected in the 1960s. While imperceptible to humans, this rhythmic vibration is believed to result from interactions between massive ocean waves and the continental shelf or volcanic activity near specific regions. Meanwhile, Earth's rotation adds another layer of complexity. Depending on your location, you could be spinning through space at over 1,000 miles per hour. Changes in Earth's rotational axis, influenced by shifting water masses and climate change, further highlight the planet's ever-changing nature. The Antarctic eruption that could change everything. Imagine an emergency alert. Leave all belongings and seek safety immediately. The southern continent has erupted. This is not a drill. Chaos unfolds as darkness engulfs the skies from Australia to southern India. A massive Antarctic eruption triggers tsunamis and ash clouds, consuming everything in their path. Antarctica, a land of ice and extremes, hides a fiery secret. 138 volcanoes, 91 of which lie beneath its icy surface. If one of these dormant giants were to erupt, the resulting heat could melt the western Antarctic ice sheet, accelerating sea level rise and devastating coastal areas. The ever-changing Earth, from the volcanic forces beneath Yellowstone to the hidden depths of Earth's core and Antarctica's ice-encased volcanoes, our planet is a dynamic system of creation, transformation, and renewal. Whether it's the rock cycle, tectonic activity, or the mysteries of the deep sea, understanding Earth's inner workings is vital for our survival and safety. Yellowstone's supervolcano is both a natural marvel and a potential harbinger of global catastrophe. While current activity levels are not cause for alarm, the shifting magma reservoirs and historical precedent highlight the need for vigilance. As researchers continue to uncover the secrets of this geological giant, one thing is clear: Yellowstone's future remains a dynamic and awe-inspiring mystery. If you found this exploration of Earth's immense power intriguing, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest videos. Let us know your thoughts in the comments. What do you think the future holds for Yellowstone and our ever-changing planet? Until next time, stay curious, stay informed, and stay safe.